Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to be talking about something that's been going on for a long time. And of course, some of you can guess what it is, but in this episode of Musings, which is number 18, I'm going to talk about mainstream ignorance and stupidity. So let's begin. Now, this morning, somebody got on this new calculus Discord channel and asked me why this here is wrong. Okay. So I gave him a link to study, and he didn't study the link, but he wasn't interested in learning anything. He came on here like every mainstream math academic who suffers from Dunning-Kruger. The majority of them do suffer from Dunning-Kruger. And he came on here trying to convince me that what he believed is true. So this wise person here said, better not waste time with you. Study JG's videos. He's correct, but of course, uh, this little idiot Gab VY didn't heed the advice. So anyway, let's get down to the point. So he says, one point is that the definition of the derivative is circular, but I don't see how that could be. So he finally gets to read the first point. So then I begin to engage him. So I say, look, the limit as we're dealing with this function here, by the way, we're dealing with a function f of x in his example is equal to x squared, okay? F of x is equal to x squared. So I tell him that the limit as h approaches 0 of 2x plus h is never equal to 2x. Okay? So he says, yeah, but it's a removable discontinuity. I don't know how he got even to discontinuity, never mind removable. There is no discontinuity here. Look. This curve looks something like that. And at any point there is no discontinuity. And if we have a secant line like that, that would be h, this distance here, okay? Now, if the secant line becomes smaller, the slope of this secant line, which is given by, in fact, it's given by f of x plus h minus f of x over h. It turns out to be 2x plus h, okay? So this is defined for all values of h. But when we talk about discontinuity, we're not talking about discontinuity in terms of h. That's garbage. The function variable is, or the function is being described in terms of x, okay? And of course, the straight line y is equal to 2x is not discontinuous anywhere. So I don't know where he got that thing about discontinuity. It's just a total bunch of crap. I think maybe what he meant is that this isn't defined, and in which case he should have answered. Yes, it's not defined, so it's a problem. So here's my response: what? There is no discontinuity there. You're just parroting things you don't understand. So again, I ask him, what is 2x plus h? Tell me your answer. So he doesn't. He says. Then he doesn't. He doesn't answer immediately. So I keep on insisting. I want an answer. So he says, this is his answer. It's a function in terms of x and h. No. 2x plus h is not a function in terms of x and h. It's a function in terms of x only. H is a constant distance. This is a constant distance for every one of these secant lines. Look, if you have secant lines like that, h is fixed for every one of those. It's constant. There's nothing discontinuous or approaching anything. So he says, so I tell him, nope, wrong. And then he says, what is it then? So I tell him 2x plus h is the slope of the non-parallel secant line between these 2 points. It is always defined as long as there's a secant line there, right? But if you have 0, then it's not going to be defined, right? Look. So if this is the slope of the secant line, which I've told you here, If h is 0, then you don't have a secant line. So you've got a problem, you see? And mainstream derivative is defined in terms of this uh, ethereal, vague, ultimate ratio. Somewhere at infinity, this 0, 0 thing, as that idiot Gilbert Strang from MIT says, gets close to limit or something, some shit like that. If you watch my video called The Dick Picture, Part 1, it explains those things. But I'm not going to go into that right now. Anyway, so then he says, what? 2x plus 0 is equal to 2x. Uh, but then I tell him, look, h cannot be. If h is equal to 0, what happens to this ratio? It's undefined, right? So you can't have h undefined before and then defined afterwards. So you can't turn around and tell me here, okay, I'm gonna pretend h is defined now and just go ahead and cancel out the h's. And by the way, in any of these secant line slope, as I've explained in my historic geometric theorem, which I'll give you a link to, it doesn't matter what function you have. H is always a factor of f of x plus h minus f of x. It can be a trigonometric function, a logarithmic. It doesn't matter what the function is. It will be a factor. Look at it. This is a geometric proof. Study it carefully and you'll see that what I'm telling you is correct. Okay? Now, so then he says, and then he says to me, of course, but that's only coming from the original expression. I don't even know what drivel he's writing there, but he says limits don't require the value to be defined at the point of accumulation, whatever that is. And what we do is remove the discontinuity. There is no discontinuity at h equal to 0. So I'm getting really fed up now. And I repeatedly ask him, and I'm telling him again now, so he's contradicting himself. I said, where is the discontinuity in x squared? And he says there is none. Well, that's where discontinuity applies. Discontinuity doesn't apply in terms of h is equal to 0. As I just explained to you, h is not the variable here, okay? H doesn't vary. X is what the function is defined on, not h, x. So then he tells me you're being very rude, and again, uh, he continues to do this drivel about discontinuity, and finally I've reached the end of my patience, and I tell him that h is the slope difference. It can be anything, from 0 to anything. If h equals to 0, then you have the line y is equal to 2x. There is no discontinuity there. But he wasn't here to understand. He was here to argue. So then he says, the discontinuity is in the original expression. Well, that's nonsense. Expressions don't have discontinuity. Functions have discontinuity, may have discontinuity. So he's totally confused about expressions, functions, etc. Now, your mainstream professors are a bunch of incorrigible, stupid morons. Okay, your calculus professors do not understand calculus, never have. And I was the first to solve the tangent line and slope, or the slope and area problem. And I actually gave you a fix for your bogus mainstream calculus. It's called my historic geometric theorem of January 2020. It fixes your bogus calculus. In other words, whatever I tell you here, I back up with 100% geometric proof. What you have in your bogus mainstream calculus is a load of shit, like the shit for brains that your math teachers and your calculus professors have. So, look, don't listen to those morons. Just study what I'm telling you. So download this link here. Don't believe me. I'm not asking you to believe me. I give you all the proof here. I tell you everything you need to know here. Don't fall for the drivel of your math teacher or calculus professor who's just a stupid chump, okay? Suffers from Dunning-Kruger just like all of you do. That's pretty much it. If you're not already a subscriber, become a subscriber, click like, follow me on academia.edu. By the way, to read this article on academia, you have to log in first, okay? And then go to the link. Otherwise, it'll tell you page not found, or you're in the wrong aisle, or something to that effect. So if you're not already a member, become a member. And also on my channel, I have a members only subscription. And if you go to any of my videos and click on them, there's a little join button. For $4.99 a month, you have access to a lot more information that I do not share with the public. So at present, I am offering to you free of charge a fantastic book. Hang on a second. This book here. It's free of charge, and you can either buy it here if you want to support me, or you can get it on academia.edu. I'll place a link to that too. And by the way, you have to log in there. But it's called The Importance of Learning the Right Way, and what does division mean in mathematics, and how does it affect all other arithmetic concepts? Let me tell you, this is a book that will change your whole career in mathematics. No one understands mathematics as well as I do. No one. I was the first to explain where you got arithmetic from. Okay. I explained it 100% correctly. And I do that also in my article called Gabriel Arithmetic, to which I'll place a link to. Okay, it's this article here. And you have access to all these articles if you log into academia. Look at this, Gabriel Arithmetic without numbers. It's already, actually now it's closer to 0.5%. This is an old print. So I explained to you where you get arithmetic from. You see, your professors can't just turn around and say, we define this or we define that. You can't do that. I mean, that's really stupid. For example, let's just clear this out and think about this for a second. You can't just say define X, okay, and then build logic on that. Because let's say you define X to be infinity, okay? Then according to the stuff you parroted in your mainstream learning, X plus X is 2X, right? Oh, all of a sudden you'll have a contradiction here because that means 2 times infinity, right? And that's nonsense, obviously. I mean, this is Cantor set nonsense. Cantor set theoretical nonsense. But I'm just showing you that you cannot just say define something without thinking about what you're defining here. It has to be explained in the spoken language, okay? The spoken language. Every symbol you use must have a clear meaning. You can't just say define X and stick your finger up your rear end and say, okay, X plus X is equal to 2X. That's not the case. Depends what is X. So if you define X to be a number, I mean, what comes to mind to me now is that idiot Giuseppe Piano who said, 0 is a number. What on earth is a number? Nobody has defined that except I. I, the great John Gabriel, defined number for the first time in history. Okay. If you want to learn more about that, you come to my channel and to my academia page and you read these articles and you'll learn mathematics for the first time in your miserable lives. I'm John Gabriel and this is New Calculus Channel. Till next time, goodbye.